In lesson 4.1, we're going to be talking about congruence and transformations. We touched lightly on transformations in chapter 1, and in lesson 4.1, we're going to expand on that. So we had discussed previously that a transformation, when something undergoes a transformation, it undergoes a change. It could be a change in the position, the shape, or the size of a figure. When you were younger, you learned those transformations as the slide, the flip, and the turn. And now we have kind of added some new vocabulary, and we call them the translation, the reflection, and the rotation. I also wanted to remind you that in our textbook, they will call the original figure the pre-image, and the resulting figure is the image. So that's kind of the before and after. Taking a look at example A, they're asking us to apply the transformation M to the polygon with the given vertices. Then they want us to name the coordinates of the image point and identify and describe the transformation. So I've went ahead and I have plotted my points P, Q, and R. And if I were to apply my transformation is given here in arrow notation. So this basically says take your point x, y, which would map to the point x minus 4 and y plus 1. So I'm going to be finding my new coordinates. I'm going to take my x coordinate and subtract 4, and my y coordinate and add 1. And I'm going to do that for each point. When I find my new coordinates, I'm going to call them P prime, Q prime, and R prime. So again, to find P prime, if I take 1 minus 4, I get negative 3. And 3 plus 1, I would get a positive 4. And I'm going to do that for each of those points. And now I'm going to go ahead and graph them, or to plot my points. When you are graphing, I do like you to label your coordinates so that I have labeled them P prime, Q prime, and R prime. I've applied my transformation, I've named the coordinates, but now I need to identify and describe. Well, looking at our two triangles, here is my pre-image to my image. I can see that that was simply a translation. And to describe it, I'm going to describe in which direction or how much. Well, I could compare point Q to Q prime. I can see I've moved to the left and I've moved up. So describing that, I'm going to say that we moved left 4 units and up 1. Looking at the second transformation, my rule says to take my point x, y and map it to x, comma, negative y, or really that negative sign meaning the opposite of y. So I have A, B, C plotted on my graph. I'm going to go ahead and find A prime, B prime, and C prime. I know that my x value is going to remain the same, but my y value is going to be the opposite. And in this case, all of my positive y values are now going to become negative. I'm going to go ahead and do some graphing. And then I'm going to compare my pre-image to my image. Well, I can see that this is going to be a reflection. If I had to describe it, I say, well, Specifically, it is being reflected over the x-axis. Taking a look at the third transformation, my rule at the top tells me I'm going to take my rectangle, RECT, I'm going to map it to the point y, negative x. So they are switching the coordinates and they are making the x the opposite value. So my r prime, if I go ahead and switch them, I would have 0 and I would have a positive 3 because that coordinate changes value. Once I have found my new coordinate points, I'm going to go ahead and graph. Now this one, as I look, might be a little bit tougher to tell, but comparing r to r prime or e to e prime, I can actually see that they have made a rotation. Now the rotation is going to be about the origin, so we can imagine that there would be a tack holding this coordinate plane at the center, and that is how it would rotate. If I were describing it, I can see that it's moving this way, and so that would be a clockwise rotation. And actually, specifically, it would be 90 degrees. How do I know that? Well, if I compare from my point of rotation, like point R to R prime, that is a 90 degree angle. Or, for example, E to E prime, I can see that's a 90 degree angle. And that would be true for each coordinating point. So it is a clockwise rotation of 90 degrees. Finally, my last transformation asks me to take xy and map it to 3x, comma 3y. So I'm looking to find k prime, l prime, and m prime. What do they want me to do here? Well, they're going to refer to that 3 as a scale factor, and they actually are wanting me to do some multiplying. So when I take and I multiply by 3, I'm going to end up with a negative 6, negative 3, and so on. And now I'm going to go ahead and plot those points. And it's quite clear to see here that obviously my image is a larger triangle. This type of transformation is called a dilation. And if I were to describe the dilation, well, sometimes they may ask you about the scale factor. My scale factor is 3, as we said. But I may say that it is a stretch or it is an enlargement. And it has a center of 0, 0. They refer to that scale factor a lot of times with the letter k, so I may just put k equals 3 to describe that. So down below, a dilation stretches or shrinks a figure. The description of the dilation includes the scale factor and the center of dilation. And like I said, our center is 0, 0, and in all of our questions for 4.1, we're going to use a center of 0, 0. Now, as you look below at the bottom, we have kind of a summary of our transformations. These are the 4 that we have talked about, and they describe our rules. So a translation, I know the rules written in this form, x plus a and y plus b, where a tells me how many units it's moving horizontally, and b tells me how many units it's moving vertically. Anytime we put a negative sign in, like here, we are going to end up with a reflection. So when we have a negative x, I have a reflection over the y-axis, or a negative y is a reflection over the x-axis. When I do some switching around and I add a negative is when we end up having a rotation. And you can see here that if you look up the rule, it describes it, whether it's clockwise or counterclockwise. And if you happen to have a negative x comma negative y, it ends up being a rotation of 180 degrees. And then finally, our dilation with scale factor of k. An isometry is a transformation that preserves length, angle measure, and area. And because of these properties, an isometry produces an image that is congruent to the original, or to the pre-image. So an isometry, if you think back to our first transformations, when we translated, our images were congruent. When we reflected or when we rotated, they were congruent. So those are going to be considered isometries. Another name for that is a rigid transformation. And like I said, our rigid transformations are going to be those 3 right there. They produce images that are congruent. On the other hand, a dilation with a scale factor of not equal to 1 produces images that are not congruent to their pre-image. And so a dilation is not going to be considered an isometry or a rigid transformation. The second types of questions that they're going to ask us is going to be similar to those in example B, where they want us to determine whether our polygons are congruent, and then to support our answer by describing the transformation. So I've went ahead and I've plotted A, B, and C, and we're going to kind of treat that as our pre-image. And then we're going to plot P, Q, and R. So let's take a moment to do that. Now we have to decide if they are congruent. Well, really, to be congruent, we would have to have either a translation, reflection, or rotation rule that would map one to the other. And it appears that these are congruent, but if I just checked my corresponding vertices here, let's say I move down and to the left, all of those should be the same to end up in the corresponding vertices. So I'm going to say that yes, these are congruent because I believe we can use a translation rule to map one to the other. Now I could describe it in words, moving down and to the left, down 3 and left 1, or I could go ahead and I could write that rule in arrow notation. And here, this shows that we are really moving left 1 and down 3. Mapping ABC to PQR. In the very last example, again, we're going to plot our points for P, Q, and R. And again, just by eyeball, it appears that these are going to be congruent, but I'm not totally sure. One way, instead of comparing the graph, I could also look at the corresponding coordinates. And I do kind of see that there may be a relationship there. In fact, it looks like they switch my numbers around and that the y-coordinate changes value. Well, as you recall from our previous page, you may find that rule right down here, switching the x and y around and changing the value or the symbol or the sign of y tells me I do have a rotation 90 degrees counterclockwise. So are these going to be congruent? I'm going to say yes. We could use a rotation. And to map ABC to PQR, we could, again, write the rule. This rule here shows me switch the x and y, change the sign of the y coordinate, or I could simply explain it that it is a counterclockwise rotation of 90 degrees. Technically, about the origin. If you'd like to see more examples, you can check out the online videos sponsored by our textbook. And if you have more questions, please stop in and see me.